Well, good morning, everyone. Welcome to the 2020 Engineering Project of the Year Awards finalist presentation for the large category. We are so excited that you're all here today joining us in this competition. And we have like a day plan ahead for you all. Just a few housekeeping items before we start. Please make sure you mute your mics and turn off your webcam. Especially during a presentation that is not yours. The recording is processed, but for the time being, we plan to only distribute it to the people who are within the competition, so just the finalists and the volunteers that you see here. Please do not send the Zoom messages to everyone or to judges during the presentation, even though you have the option to, because we will be on the internal side, we'll be using that platform to coordinate amongst ourselves. You can feel free to private message the finalists or other volunteers in case you have any questions. Before we start, I would like to begin by acknowledging the indigenous people of all the lands that we are on today. While we meet today on a virtual platform, I would like to take a moment to acknowledge the importance of the lands which we each call home. We do this to affirm our commitment and responsibility in improving relationships between nations and to improve our understanding, commitment, and to reaffirm our commitment and responsibility in improving relationships between nations and to improving our own understanding of local indigenous peoples and their cultures. In York region, we acknowledge the ancestral and ceded territory of all the Haudenosaunee, Anishinaabe, Mississauga of the Credit First Nation, and Mississauga people that call this land home. Please join me in a moment of reflection to acknowledge the harms and the mistakes of the past, and to consider how we can each and how we are in our own way try to move forward in a spirit of reconciliation and collaboration. So as you all know, the award is aimed to recognize projects by licensed professional engineers and their contributions to the community. It raises public awareness of the engineering profession, connects these local engineering companies to potential community partners and talent. And this year, we're very excited to be giving out 3 places. So first, second, and third place for each category. And the virtual award ceremony will be on April 7th, 2021, 5:30 to 7, and that will be open to the public. We're very thrilled to introduce our star-studded judging panel today, and the first is Marissa Sterling. She is the Professional Engineers Ontario President. She is also the Assistant Dean and Director of Diversity, Inclusion, and Professionalism at the University of Toronto's Faculty of Applied Science and Engineering. Second, we have Manal Chowdhury. She is the Technical Manager, Grid Innovation at Electra's Green Energy and Technology Center. She is also part of the winning team for the large category of the 2019 Project of the Engineering Project of the Year Award. Next, we have Anna Murray, who's the Proton Exchange Membrane Technology Product Platform Manager at Cummins Inc. She is part of the winning team for the winner, one of the category winners for the 2018 Engineering Project of the Year Award. We have Helen Dang, who's a rapid transit sponsor at Metrolinx. And last but not least, we have Annabelle Lee, who is the chair at PO York chapter and a K-12 IT security specialist at IBM. So our schedule today is each finalist will have strictly 10 minutes of presentation time and up to 7 minutes allotted afterwards for question and answers by the judges to the finalists only. So the public or any observers, you're not allowed to ask any questions of the finalists. In case of technical difficulties, presenters have 5 minutes to come back and reconnect and resume at the slide and the time that they stopped at. For example, if you've gone through 3 minutes of your presentation, if you run into a technical difficulty, you can come, as in you disconnect and come back and resume at your last 2 minutes and continue for the rest of the 8. The judges have already declared their potential conflicts of interest, and we will be adjusting that accordingly on the back end for the scoring. But regardless of whether they are participating in the scoring or not for each of the projects, they will be participating in the questioning of our finalists. And lastly, as we said before, finalists are expected to stay for the full duration of their category presentations. During the wrap-up, I will give a verbal indication that you are able to exit, and that is when the finalists should exit. Do you have questions during the session? For applicants, please ask your VAH prefix, so that's Dami Lari in the morning, through private message. Anybody who has a V prefix is a volunteer. If you got disconnected, don't worry. Come back to the same link, we'll let you back in. And if you don't know who to reach out to, just go Zoom message VZ Reza, and he will direct you to the right person. Okay. So today's volunteer team is not just me, it's 6 of us. It's Reza, Lisa, Demi, Lare, me, myself, Huzaifa, and Hani. In addition to that, you must have interacted with some of our committee members. This entire competition is definitely a team effort, and it could not be what it is today without the rest of our volunteers as well. So without further ado, let's begin with the finalist presentations.
Okay, I'm just gonna check to make sure it's scrolling, and it is scrolling. So good morning, everyone. On behalf of the project team, I'd like to thank you for this opportunity to showcase our project and try to convince you that it is worthy of the Project of the Year award. My name is John Pham from Wood, and joining me here today, we have Christian Humont, the design manager of the project. Wood, as part of a project consortium led by EllisDon, is currently working on executing the design build for the Rutherford GO Station Improvements Project. This project is part of Metrolink's wide expansion program to accommodate all-day train services in both directions along the Barrie Rail corridor between Barrie and Toronto. On your right, you'll see a map of the Barrie Rail corridor, and highlighted is the Rutherford GO Station location. The planned increase in train service and the station improvements will help promote public transit use, and the new grade separation at the site will help eliminate congestion at the existing at-grade road and rail crossings, where cars currently have to sit and wait with every train passing, which causes congestion along Rutherford Road. These and the technical merit is what we believe makes this project stands out and worthy of the Project of the Year award. On your left, bottom left, you'll see an artist rendering of what the site will look like upon completion. On your right is a picture of current conditions. It will look a lot nicer without the snow in the winter when construction is done. Design on this project started in November of 2018, and we progressed on design until about fall 2019 when construction started. Substantial completion is expected by spring 2022, and we are currently on track to hit that substantial completion date. The project has a construction value of $239 million. Shown here is an overview of key project elements. You'll see, starting from the bottom left, a new parking structure with integrated station building. There's updated parking lot layout, passenger pickup and drop-off area, and bus loop, all updated to provide ease of transition between travel modes. Again, the theme of improving and encouraging transit use is all throughout. There's a new rail bridge to separate the road and rail traffic, right over here, if you can see my cursor, to improve the flow of traffic along Rutherford Road, eliminating the need for vehicles to wait for trains. Adjacent to the rail bridge is a pedestrian bridge to connect the multi-use pathway on the north side directly to the station building. So along these orange is multi-use pathway, and there's also on-street bike lanes as well, again, to promote multi-use active transportation. There's a new stormwater pumping station to pump stormwater away from the depressed roadway during rain events to avoid delays on the road. And within the rail corridor, to accommodate the increase in train service, there's a new east track and a new east platform with upgrades to the existing track and the existing platform. In terms of impact to York Region and neighboring communities, the new station improvements and grade separation will encourage use of public transit and active transportation modes, which means taking cars off the road. What this ultimately does is improve network capacity and connectivity, quality of service for pedestrians, cyclists, transit users, and motorists. It improves capacity and level of service for movements of goods as well along Rutherford Road. So those are heavy trucks. The project will improve efficiency and options for public transportation. The increase in train service will improve travel between urban centers, essentially better connecting major cities along the Barrie Rail corridor all the way from Barrie to Toronto. By removing the existing at-grade crossing and eliminating the need for drivers to wait at the existing rail crossing, it will enhance community safety. This reduces potential collisions and delays to emergency vehicles. Increase in train service will enhance access to high-capacity transportation options to downtown Toronto, which means more access to jobs and growth. So overall, the project will enhance the image of York Region as a place of high-quality transit. From an environmental and social sustainability aspect, the new station improvements and grade step will provide safe and accessible station that will promote and encourage use of public transit and active transportation modes such as walking and biking. By reducing the number of personal automobile trips, it means we're moving more people with less energy, and this will result in a reduction of emissions and the total number of collisions. Also, by removing the at-grade crossing, it eliminates the need for vehicles having to wait for passing trains, and which enhances safety because you avoid rear-end collision between cars and trains, and it also improves the local air quality from lack of idling now from cars waiting. The Rutherford GO Station site design and construction aim to achieve LEED Gold certification. I think we're more on track to potentially get silver certification. What sets this project apart from other projects of similar scope is the presence of an interlayer system of aquifers at the grade separation site. So this is where we get into the technical merit and some of the innovation. So as shown on the screen, you'll see that there are two aquifers. There's a top here is a lower upper aquifer consisting of sand and silt, and below here is a pressurized low aquifer of sand and gravel that is separated by an aquitard of silty clay. When I refer to the pressurized low aquifer, sometimes referred to an artesian aquifer. So it means the water in that aquifer is under enough pressure that when it's tapped, the water is going to reach the ground surface about 15 meters above. So under existing conditions, if you have to drill down here, the water will go all the way up to the road surface. So as such, our design we had to optimize our design in such a way to compensate for the hydrostatic pressure, the uplift from underneath, and to avoid permanently depressurizing that lower aquifer. So one of the innovation and the technical merit we find is that to counteract buoyancy, our final design is an optimized combination of a total mass of a below grade concrete slab structure, this tub structure here. It's an inverted, see, we refer to it as the tub. We also use the weight of the fill, the granular and the asphalt. We incorporated permanent tie-down caisson to help bear the weight and resist the uplift pressure. And another final innovation was that we included shear keys to engage the weight of the secant pile walls that were originally intended for shoring for an excavation, but we designed it for permanent condition, and we engaged that weight to help resist the uplift. The grade separation, the tub structure as well, is also designed to be a watertight structure. There's a waterproofing membrane highlighted in green that wraps around the entire permanent structure. It's like a lining of an in-ground swimming pool. This will ensure that there's no permanent water from underneath that can come up, pushing through the tub, and that we avoid depressurizing the low aquifer. So you can imagine from the bridge out, 150 meters on either side of the bridge, is this tub structure. And at the end, there's two vertical walls going straight up that prevents any water from going into the tub from below or from the side. The overall tub structure is approximately 38 meters wide to accommodate the new roadway, and it's about 300 meters long, as mentioned. There's a quick video here showing the construction approach. It's actually a video rendering completed by Metrolinx. It's a quick video, so I'll try to go through it here. So as you can see, this is the site. The first steps coming in is the shoring system. Concrete piles are drilled to form the secant shoring to support the excavation, starting on the east side to the west. And you can see all the excavators are working really fast to excavate. At the same time, there's constructing the rail bridge. We install caissons for the bridge, form the abutments and piers. Excavation happened, construct underpass slab structure, which is the black area and the gray that you see there with the wall, uplift wall. And the train traffic switched to the west. The whole process repeated on the west side. Pedestrian bridge built, road built. See? 2 years of construction in 40 seconds. A couple of videos here of current status. We have caisson, if you can see here my cursor. These are the drill caisson that we drilled down to support the slab. This is all the reinforcing bar for the underpass slab, that tub that you'll see. Here is some progress overview of the tub. Here you see the secant walls on either side. The enclosed here is where the shear key is being formed. In terms of commercial viability, the new station improvements and grade separation will accommodate an increase in train service and frequency, which help promote public transit use, and the grade separation will eliminate congestion at the existing at-grade road and rail crossing. Increasing train service will increase transportation capacity to support access to and for the growing communities in the surrounding areas. So there's a lot of congestion within York region along all the east-west throughway in the corridor, and even the highways within the greater Toronto and Hamilton area. And it's not always feasible to build more roads to expand the highway. We can't just add another highway. So what Metrolinx has found is that expanding the GO network, where there is property and room, is probably the most cost-effective way to increase transportation capacity versus widening or building more roadway. Because as you increase transit services, you get more cars off the road, which then build more capacity. As well, from a viability point of view, increased ridership will contribute to a rail system that is more self-sufficient by covering operating costs with revenue from fares. I'm slowly running out of time. So again, I'd like to take this opportunity to thank you for your time to allow me to present, and I'm happy to answer any questions. Actually, just 20 seconds. I'm going to hit my last point, is that the project elements were designed with consideration for cost-effective operation. So we designed the tub and the bridge in two independent of each other so they can be maintained separately without impacting each other. And they were designed for a life of 100 years. 10.
Thank you very much. Your time for your questions will begin, 7 minutes will begin now.
John, hi, it's Marisa. Thank you so much for your presentation. I have a quick question for you. Is there any metrics that you can associate with the improved network capacity? Are there any numerical goals, or can you compare those metrics to other projects in terms of some of the improvements that will be possible because of this?
So that is a great question, and from my transportation background, it is actually a very tough metric to analyze, because what happens is it's not, when you analyze engineering metric, is usually very limited variables. When you have a lot of different variables combined, it is very difficult to come up with a metric. I know, and what happens is you have a rail corridor. When you take people off, it's hard to anticipate the number of cars that can get off the road. And also in transportation, there is this phenomenon known as supply-induced demand. When you take cars off the road, all of a sudden, maybe other cars will come in as well. So we can always say that we improve capacity, but it's hard to justify how much. But from a Metrolinx number, there is a number floating around, I believe, the top of my head is that by 2055, Metrolinx anticipates to have 200 million riders on the rail corridor, and if you take that into consideration, that's a lot of cars we're taking off the road. Based on that alone, it's hard to say how many of those cars are actually taken off Rutherford, right? And how many cars taken off the adjacent corridor, because this corridor is from Barrie all the way down to Toronto. We don't know what the aggregate effects of each of these crossings or each of these station improvements are going to be. And if someone's telling you that's a set number, they're almost lying. It's really hard. It's a great question, and I wish I had a hard set number for that, Marisa, but I really don't.
Yeah, plus this project, it's in the middle of Barrie corridor, like John mentioned, is more than that. This Barrie corridor in Rutherford is the core of your region, and just imagine how many people is going to use this station. It is a small location, and just besides that, this station and the grade separations and everything that we did in here consider all the other future elements that Metrolinx is working right now, is the electrification and is the level boarding. So that, and this project included provisions for those futures.
Thank you so much.
Thank you for this presentation. Very interesting project. You had mentioned the construction took 2 years, but I actually want to understand a bit more about the design phase, particularly around what you call this tub. How long did that take? Was this part of the project? And can you explain to me maybe some of the risks that you looked at and how to mitigate those?
Yeah, for sure. That's a great question. So even though construction is 2 years, the design has probably ongoing for over 2 to 3 years, actually. So this, as I mentioned, this is a design build project. So there is a what in a typical design build project is what's called project output specification, which does have a conceptual layout of what the client ultimately wants. So this project, or before it was a design build, was originally intended to be a conventional design bid build. So there was a design already done that has some sort of tub that's similar to ours. But what happened was it was a thicker tub and the road fill was a lot thicker. So you see this area here was filled over 3.5 meters. So it was sheer weight. But what that means is it's going to be significantly more excavation, and the excavation will be a lot deeper. So if I go back to this, I'm trying to go back one slide. If I go back to this slide here, so you see this black line here is what the road profile is, our road profile, and the red line is the bottom of the tub structure. There's not that much space. There's about 1.5 meters to 2 meters between the bottom of the tub, the excavation, and the pressurized lower aquifer. The original design was because of the thicker road bed and the thicker tub, was almost touching this pressurized low aquifer. So the risk of puncturing that aquifer was too great during construction. So one of the optimization is we worked really hard with EllisDon's construction science team and our senior designer to look for ways to minimize that risk, because you don't want to puncture this pressure low aquifer, because not only is it going to be a risk during construction, it's going to be a big risk during full-term operations. You're gonna have this massive pressure all the time, and the water, it looks simple on a cross section, but it isn't. This water is moving north to south. This section is looking north, so there's gonna be water pressuring everywhere. So what we've done is we looked at different options to minimize that risk during construction. So what we did is, instead of having that 3.5 meter fill of road, we cut it down to about 2.5 meters fill, and we reduced the tub thickness from 1.6, 1.8 to 1.4. So reduce the thickness, we reduced the fill, but what we had to do instead then, we had to incorporate these permanent tie-down caissons to help weigh down the tub, and we engaged the shear key of the shoring, which we haven't really seen something like this done before, but we looked at different ways that will help expedite construction and reduce the risk of puncturing that lower aquifer. And at the end, we came up with about 53 of these permanent tie-down caissons spread across the length of this 300-meter tub. So the caisson help resist tension and uplift, to help keeps it down. Imagine it's like an anchor. And at the same time, the caisson has skin friction of the soil to also help resist uplift. So combining all of this is an optimized combination to come up with this tub. And you see this mass concrete here too. We added this multi-use pathway. We made it a really mass concrete for the weight to help reduce the width. And the risk is you don't want to increase the depth of this too high either, because there's actually a limit on the vertical clearance between the top of the road and the bottom of the rail bridge, because there is a minimum clearance you have to meet, and you cannot move the profile of the track. Rail has very tight restriction on profile, so we tried our best to maintain that profile along the whole north-south. I hope that answered your question a bit.
Yes, thank you.
No problem.
Thank you, judges and our presenter. That is the end of your time for questions. I will now give 6 minutes for the judges to write down their answers, because I have forgotten to give the 3 minutes for the first presentation. So 6 minutes begin now. Judges, please take the time to write down your scores.
Thank you very much.
Thank you.
All right, judges, you have 2 more minutes to write down your answers. In the meanwhile, I will get our third presentation set up here. So just note for all presenters, if you're clicking volume up or down when you're doing your presentation, you're actually controlling my computers, just so be aware of that. But yes, okay. So Hamid, I will give you please request a remote controlling around a minute. I'll give you a verbal indication and we can start your presentation off. Okay. And I will approve that request. I do see that coming through, so I will remove that request soon. Okay.
Do I have access now or no?
Yes, you should, but please do not begin your presentation until I give you verbal indication to do so.
Okay.
Okay, just you have about 30 seconds to wrap up your entering of the scores. If you want to make notes, feel free to do that on the spreadsheet. Okay, 10 seconds. Okay, so Habib, please begin your presentation. Your time starts beginning now.
Thank you. Good morning. My name is Hamid, and I was a project manager on the vivaNext H2 East and H2 West project. I graduated from University of Toronto in 2013 with a civil engineering degree, and worked with other contractors from then to when I started with EllisDon in 2015. I was introduced to EllisDon through an outreach event that I'll touch on later on. And the vivaNext bus rapid transit H2 East and H2 West corridors of Rapidway is part of the broader vivaNext network that integrates into the transportation system, both in terms of transit operations and Viva stations, and was completed in January 2020 with a value of approximately $350 million. It was delivered under the design build finance model. During today's presentation, I'll go over the project summary, innovation, technical merit and distinction, environmental and social sustainability, commercial viability, and the impact to York Region and neighboring communities. Project summary. The two segments of the project site were about 5 kilometers apart and could be treated as different projects. The H2 West segment of the project was a winding along Highway 7 from Helen to east of Edgeley. The H2 East segment of the project was a winding along Center Street from Highway 7 to Bathurst, Bathurst Street from Center to Highway 7, and Highway 7 from Bathurst to Yonge Connector Route. The project consists of approximately 12 kilometers of rapidway and 10 stations. We widened multiple culverts, including the Humber River culvert under Highway 7, which required 34 bell ducts to be temporarily supported during installation. The corridor required extensive amounts of road and bridge widening to accommodate the dedicated center bus lanes. As a result of the widening, the project also involved extensive utility relocations and repairs to storm, sanitary, and water mains. Road and culvert widening and ramp realignment was also completed in the vicinity of Highway 7 bridge over 400 for MTO. In terms of innovation, technical merit, and distinction, working on this project has enabled EllisDon's building sciences team to take challenges head on. Detailed traffic management plans were created as separate staging plans for each phase of the project required 2 live lanes of traffic for a majority of construction time. Extensive traffic management was implemented along one of the busiest highways in North America to realign the southeast-west ramp from Highway 400 to Highway 7. We also implemented BIM to mitigate risks, especially for dry utilities. 5 utility agencies that were impacted by the widening works were Electra, Enbridge, Bell, Rogers, and TELUS. We also relocated water mains along Center Street, Bathurst Street, and Highway 7. We were a recipient of 3 major awards, as you can see on the screen as well. This BIM video shows the H2 East segment, which starts from Center Street and goes north on Bathurst Street. There were 1,500 test bits completed as part of the subsurface utility engineering investigation, and utilities were classified to different quality levels specified in ASC 3802. We modeled all the utilities to scale, introduced a standards table for clearances, and based on clash detections, the proposed alignments were finalized for the design. Joint use of hydro and streetlights helped with the congestion in the corridor. EllisDon also utilized horizontal directional drilling instead of the traditional open cut method to relocate 1.5 meters of water main along the busy Bathurst Street. Utility work was ongoing until mid-2019, and we completed the project on schedule by January 2020. Overall, the usage of BIM led to minimal utility strikes on the project as well. The next BIM video shows the widening of Highway 7 over Highway 400. The bridge deck was extended by 10 meters with 4 new piers installed to the north, and the parapet was rebuilt on the south side to accommodate the dedicated bus lanes. This is the widening to the north, and the strip in the middle is the multi-use path. Here's a picture of the multi-use path. In terms of environmental and social sustainability, we built the first multi-use path in Canada within a highway corridor that promotes active transportation. The protected multi-use path ensures safety to pedestrians by avoiding unsafe access points. Previously, pedestrians would have had to cross the ramps since the sidewalks were on the north and south side. Signal timings were optimized for the 30 intersections within the project limits in order to improve ITS within York Region. Zoom Brampton transit buses and the TTC are interconnected to the vivaNext network as a result of this program. In terms of environmental, soil excavated across the project, specifically within the roadway that met the MECP Table 2 SCS, with the exception of salt, was reused within other excavated areas needing fill. We did not treat the soil excavated as waste where there was potential to reuse it as fill across the site. This minimized the environmental impacts to the community. Commercial viability. Local outreach events were held in Thornhill and Woodbridge, provided employment opportunities to those who want to work in York Region, which is how I got my start with EllisDon. In addition, exposure to the construction industry was made available to students through intern placements on the project sites. At any given time, there was a workforce presence of 150 workers. vivaNext H2 East and West was completed on time and ahead of schedule using advanced methods such as 4D scheduling techniques. A lot of the optimization and logic changes of our schedule were implemented using 4D method. Vehicle and pedestrian access to businesses were also maintained at all times. Impact to York Region and neighboring communities. Reduction of traffic congestion by implementing fiber connection to York Region's transit network. According to the 2019 Ontario Road Safety Annual Report released by MTO, 23% of collisions can be attributed to turning movements. Introduction of fully protected left turn phase mitigates the risk of these types of collisions. As part of the ramp realignment works, advanced transportation management system for the MTO was enhanced as well. Coordination with private developers regarding design and construction schedule was required for the ramp realignment for improved and continuous traffic flow in one area. Also during the pandemic, which we got 3 months after substantial completion, the bike lane is also being utilized as an extension to the sidewalk to help promote social distancing. Thank you for listening to our presentation. Infrastructure is the future of construction, and only 10% of the infrastructure projects are completed on time. vivaNext H2 East and H2 West was one of them. If the judges have any questions, I'll be happy to answer.
Great, thank you. The judges' 7 minutes question has started now.
This is Helen. I have a question. Thank you for the presentation. With adding this dedicated transitway into BRT into this highway, do you implement any innovative signal prioritization engineering into the design as well?
Absolutely. Like I mentioned, there were 30 intersections within the corridor, and the signal priority was implemented at every single intersection within the corridor. So that was along Highway 7, Center Street, Bathurst, and the Highway 7 portion from Bathurst to Yonge Street. So that all obviously helps with the travel time of the Viva buses.
Thank you. Could you also introduce a little bit that what's the impact to York region in terms of economic empowerment and also improvement of employment?
Well, like I mentioned, funny enough, I started my career with EllisDon because of this project, right? So it had a huge impact in the community. I live in the area and I see how the public is enjoying what was built, and we are looking forward to having more projects like this.
Do you take the transit now? With
yeah. Before I couldn't. Now I do. So I do work at the Rutherford project, so I do take the transit.
Thank you.
Amina, I have a question for you.
Yeah.
During the construction, I think I heard you say that utilities and access was being maintained. Is that the case? Was there any down time of any of these services or not during the project?
Well, the cutovers were scheduled by coordinating with the impacted community, right? And it was done during nights or weekends. We tried to minimize it as much as possible with the client's help as well.
Great, thanks very much.
Thank you.
And can you speak to how any of this technology might be used by others in the future? Has there been any discussions about others wanting to learn from what you've done and adopt any of these types of approaches?
Yeah, so I am part of the TAC subcommittee for utility relocations. A lot of the lessons learned on this job was passed to that subcommittee. So hopefully we did come up with the new standards for design build projects for utility relocations. And because we successfully relocated about 12 kilometers of utilities on schedule, and we had utility work ongoing until mid-2019. It really set a new precedence for the design build projects to try have them completed on time, right? Although utility seems to be a challenge on every project, right? We got our substantial.
Hi, Hamid. I have a question for you. Thanks for that presentation. This is obviously a huge logistical undertaking, so I was wondering if you could expand a little bit more on the 4D scheduling techniques you guys used throughout the project.
Yeah, just you guys saw 2 videos of the BIM model. What we did is we input the our schedule into the BIM model, and we could see based on the logic on the schedule how it will work out. And we broke it to different segments, right? Intersection to intersection, we looked at it. And we also had to do that with collaboration with utility companies and the client and other stakeholders in the job to make sure the abandonments timelines and the locates getting updated would work out with the next contractor that will work in the corridor. So that was the biggest benefit, right? To see what will be abandoned by when and when the next contractor can go on site to get the work done.
For sure. Thanks.
Yeah, thank you.
There are still 2 more minutes for questions if any judge wants to squeeze in another one. All right, thank you.
Just curious, what's the construction period and what's the life, the product life for this BRT?
So the construction was, for our project, it was from September 2015 and the substantial was January 2020. That was what we had originally, and we achieved it. A segment of the project was actually handed over to the client a year ahead of schedule. The Highway 7 portion from Bathurst to Yonge was completed a year ahead of schedule and separated from the rest of the project, and was taken on from was handed to York Region.
Is that designed for like 60 years or 100 years? What's the life cycle?
I believe it's 100 years.
Thank you.
Great. Thank you so much to our presenter. Judges, you now have 3 minutes to write down your responses. While we're doing that, let's get the next presenter set up. Thank you, Hamid, for your question.
Thank you. Appreciate your time, everybody. Thanks for listening.
Thank you.
Michael, if you could request remote control, just send the request now, and then I will approve it closer a minute from now when you are about to begin your presentation.
Yeah, Chris will be requesting the control.
Okay. Sounds good. Perfect. Okay. Sounds good. I will be approving it. I'll let you know verbally too once I approve it. Right now, the judges still have a minute and a half to write down their scores. Please make sure your timing devices are easily handy so that you can start your 10 minutes as soon as I give the green light to do that. Thank you. Okay, Chris, with a minute left, I'm just approving the request now, but please don't begin your presentation until I let you know that I have started the timer for your 10 minutes. But feel free to like scroll and make sure that your controls work. Just as you have around 30 more seconds to write down your responses. Okay, so Chris, please begin your presentation starting now.
Good morning, everyone. Thank you for the opportunity to present as a finalist for PEO's Project of the Year large category. My name is Chris Scott. I'm Manager of Infrastructure for York Region Rapid Transit Corporation, responsible for the Yonge Street BRT project. Today, I will be sharing the presentation responsibilities with my colleague, Michael Paddocks, who is a project manager that was able to see this project through from award to completion. We'll first begin with the project overview. Our presentation showcases the Yonge Street Bus Rapid Transit project, a complete road widening to accommodate 9 kilometers of dedicated rapidway. It is divided into 2 main segments within Newmarket and Richmond Hill. It is a transformative project that upgrades utilities and infrastructure, provides dedicated lanes for buses and emergency vehicles, offers comfortable and accessible Viva stations with heated enclosures for customers, and has a beautiful streetscape for pedestrians and cyclists to enjoy. The design build project had an original contract value of $260.5 million and began construction in 2014. In 2020, the project reached substantial completion and the rapidway was fully operationalized. For the Innovation, Technical Merit, and Distinction category, we focused on our utility relocation program due to the complexities we experienced and the unique plans and solutions developed through the course of the project. Yonge Street is the most historic and heavily traveled corridor in York Region, with a complex network of existing transmission and local distribution utilities that were in conflict with the proposed infrastructure. This required approximately 95% of all of the existing utility plant to be relocated, with a projected cost of $220 million. To put this into context even further, this 9-kilometer project required more utilities to be relocated than any of all of our, or actually of all of our other vivaNext projects combined within the 34-kilometer phase 1 network. As this was a design build contract with a stipulated completion date, the project schedule was tight. The extensive utility relocation work had to be completed simultaneously while maintaining traffic, pedestrians, and traffic operations. As shown in the background of this screen, the project was required to develop an intricate utility relocation schedule. Our strategy required the relocation works to be sub-segmented based on conflicts, utility service areas, and available project space to enable parallel utility relocation work and maximum contractor density. To enable this schedule compression, we developed a corridor management plan to maintain individual constructor responsibilities, as the utility relocation work was self-performed by each of the respective utilities. This ensured that the owner did not become the constructor. This plan included a number of tools and processes to maintain the time and space requirements, which was ultimately accepted by the utilities and the Ministry of Labor. Excuse me, through extensive consultation. Over the course of the entire 3 years of the utility relocation program, with more than 12 different active constructors performing work on behalf of the utilities and the project did not receive any notices from the Ministry of Labor. I also wanted to mention that these innovative plans and processes that were developed through the course of the Yonge Street project have been shared within the industry and adopted by other similar projects. In addition to that, the principles have been included in Transportation Association Canada's P3 Utility Coordination Guideline that will be published shortly. As a result of the limited subsurface real estate within the corridor and to avoid sequential work, we collaborated with 3 major utility companies, Electra, Bell, and Rogers, to install their new plant in a joint use trench. This was the first time these utilities had partnered in a JUT for a reconstruction project, requiring a completely new implementation strategy for the design, tendering, and construction. The tender process was especially challenging as each utility had very different procurement practices, contract templates, pre-approved contractor lists, and administrative procedures. YRRTC was able to develop a procurement and administrative model that maintained the utility's unique practices through a 3 quotes, 1 contractor system. This approach led to 10 successful JUT tenders awarded at an approximate value of $60 million. My colleague Michael will take over from here. Thank you.
Thank you, Chris. Environmental and social sustainability. The foundation for our environmental responsibility was developed through the environmental assessment EA process and acts as our formal commitment that we will leave the natural, social, and built environments better off than they were before. We've achieved this in a number of ways. Over 4,000 trees and thousands of shrubs and flowers will be planted along the corridor in engineered planters, which include soil cell technology to increase the usable volume for soil for maximum growth, creating an urban canopy in support of York Region's greening strategy. The project also incorporated several low-impact development initiatives, including on-site stormwater infiltration through boulevard permeable pavers and tree planters. In addition, the project contributed to Lake Simcoe Region Conservation Authority's LID off-site projects to achieve the water balance criteria by offsetting the project's impacts. The project's stormwater management plan included new and upgraded stormwater conveyance systems that can accommodate a 5 to 10-year rain event. 10 new oil grit separators provide the required quality control, one of which was over 10 meters deep, which you can see in the top right-hand corner of this slide. Transit by nature is environmentally sustainable, and this project will give people the choice to get around quickly and conveniently without a car, benefiting the environment. One bus can replace up to 70 cars on the road. As recommended in York Region's pedestrian and cycling master plan, the project constructed nearly 20 kilometers of dedicated bicycle lanes to support active transportation. The project provides a complete street where people can get around on their bikes or by foot, as well as comfortable, reliable, rapid transit. Commercial viability. With York Region's population expected to increase from today's 1.2 million residents to 1.79 million by 2041, the growth must be managed strategically to reduce the suburban sprawl. The Yonge Street Rapid Transit infrastructure provides the foundation to accommodate the planned mixed-use development to achieve our complete communities. As we built the Yonge Street project, we expanded and improved essential infrastructure such as sewers, telecommunications, and water mains to meet the standards and capacities the region will need for long-term growth. To maintain a vibrant and diverse commercial community, the existing businesses were extensively supported throughout the construction. Impact to York Region and neighboring communities. Transportation and traffic congestion consistently rank as top issues for York Region's residents and businesses, so investing in rapid transit infrastructure is crucial. The Yonge Street project connects communities and improves the overall transit network in York Region and beyond. As you can see from the slide, the Yonge Street project is a central piece to the ever-growing rapid transit network being built. The urbanization of Yonge Street will improve public safety and will result in fewer collisions. On similar BRT projects, we have seen between 51% and 74% fewer collisions along the rapidways, likely due to eliminating mid-block left turns and the upgraded, fully protected signalized intersections. The Yonge Street Rapidway also provides improved travel times and responses for emergency services with access to traffic-free Rapidway lanes. The Viva Blue service along Yonge Street, which uses the newly opened Rapidway, continues to be the most utilized transit service in York Region. The 30% increase in operational efficiency and improved reliability are key to the continued growth in ridership. The Yonge Street BRT will connect customers directly to the future Yonge North subway extension, York Region's top transit priority. The photos included in this slide demonstrate the transportation of the Yonge Street corridor. The opening of the Yonge Street project was celebrated with a virtual media event on December 17th, attended by senior level staff and various levels of government, including the Minister of Transportation, Carolyn Mulrooney. The opening of the Yonge Street project marked an important milestone recognized by these individuals, and it was the final segment of the 34-kilometer network in York Region, connecting the key growth centers. These elements provide a fully integrated transit system connecting York Region's communities as well as neighboring communities throughout the Greater Toronto Area, resulting in reduced traffic congestion, increased productivity, and sustainable options for generations to come. Thank you very much, and we'd now like to open the floor for questions.
Thank you very much for your presentation. Your 7 minutes for questions begin now. Judges, please go ahead.
One thing that I heard that was interesting to me, this is Anna speaking. Thank you for your presentation. It was very interesting. But what I picked up on was the piece where we were talking about trying to get all the utilities into the same trench, and all the requirements for the different approved subcontractors. Can you explain a bit more about how that piece was managed on a technical level? Because these different utilities do have very different requirements.
Yeah, thank you for that question. The development of the joint use trench strategy was very complex and definitely took a lot of collaboration with the utilities from an administrative perspective, but also from a design perspective as well. Because typically those utilities require a certain amount of clearance from each other, where we actually stack them on top of each other, with Electra being on the bottom, Bell in the middle, and then Rogers on the top. So there was a relaxation of the clearance requirements and an intricate and adaptive design exercise that had to occur because of the number of design iterations that was required in order to get to the final design solution.
Yeah, I saw you actually had natural gas in there too with the Enbridge lines. How did you manage mixing electrical and natural gas in the same trench?
Yeah, the picture or the diagram showed natural gas within that area, but it's not actually part of the joint use trench itself.
That makes sense.
To the JUT.
Okay, so it was you had your electrical and communication lines mixed in.
Yes, correct.
Okay. That makes more sense. Thank you.
Question.
Let's talk about the. Oh, go ahead.
Who's that? Okay, I have a question. In terms of environmental impact, is there any way that you could quantify what you think that is going to be? There was a lot of discussion around the planting of trees, permeable pavers, rainwater management. But is there any way that you could sort of quantify that or benchmark that to any other project?
Michael, did you want to answer that one?
Yeah, I'm just taking a second to, against any other project.
Or against any other metrics that are out there in industry?
I don't have that, Chris. You have been on more York Region projects than I have, but we were trying to achieve the latest standards and as best we could in the situations we have, but I don't have any comparison to other projects.
And
yeah.
Are there?
Sorry, if I could just add to that. So I don't have any specific metrics to compare them against the other regional projects that I've been a part of, but I can say that the greening strategy within the vivaNext program and our Yonge Street project is state of the art. We use soil cell technology, the number of and quantity of trees planted and the survivability of those trees is definitely above and beyond through these projects compared to my experience on other suburban type regional projects.
Thank you.
So I do have a question. What is the future maintenance schedule and cost that is expected?
Yeah, that's a great question. And unfortunately, I don't have the operation and maintenance costs. I would have to reach out to York Region Transit directly to get a better understanding of that.
And I have another question. Was there any lessons learned from the earlier Markham project that was applied to this route, this project?
So at the end of each of our vivaNext projects, Highway 7, Davis Drive, the ones in Vaughan and in Markham, we do a lessons learned exercise. And so there's a long list of lessons learned that have been adapted. And those improvements have gone into each successive project. So the Davis Drive project benefited from Highway 7 and Yonge Street benefited from Davis Drive. And then the H2 West East project benefited from all of them, as it was the last procurement project. A number of things from asphalt technology to concrete, from managing pedestrians within the course of the project, maintaining access and commercial viability for the businesses. There's a long list of lessons learned that gets brought forward from each of these projects.
There's still a minute and a half left for questions, so if anyone wants to squeeze one in now, they can.
Anna speaking again. You had mentioned during the project management piece, you said some of the principles were incorporated. I don't know if I well understood, but you said into some new standards. Could you maybe elaborate a bit on that?
Yeah, sure. And thanks for the question. So I'm a member of Transportation Association Canada's Public Utility Management Subcommittee. And the subcommittee has actually recently authored a P3 utility relocation guideline, and it's in its final stages, and we're working towards publication shortly. So all of the lessons learned and the processes and techniques that have been successful on the Yonge Street project have been incorporated into this new guideline that's going to be published shortly.
Thank you very much. That's the end of our questions. Thank you to our presenters. For the judges, your 3 minutes to write down your answers have begun now. After that, we'll just do a quick wrap up of the category, and then I will let everyone, the finalists. Again, thank you all finalists and judges for coming on early on a Saturday. We really appreciate your time in applying for the award and supporting the engineering profession.
Thank you.
Thank you. All right, we're just going to wrap things up here. Can everyone see my screen? Thank you, everyone, all of your finalists for coming to the finalist presentation today. This is now the official wrap up of the large category competition. You're now free to leave the Zoom conversation. Please make a coordinated entry out because we have to begin the next category of finalists.
Thank you.
just note that, again, the virtual award ceremony is April 7th, 2021. So if you are a first to third place recipient, the latest that you get notified then by is slightly before that date. We will keep everyone posted. Thank you again for taking the time out of your busy days and your weekends, especially, to come attend our awards competition. We look forward to seeing you all, regardless of the result, apply again next year. Thank you and have a wonderful day.